Hi friends, we have studied to find the equation of straight line in different forms from the given two conditions. The use of these conditions has also been made clear from some examples.
Can you recall them, Nidhi?
Oh yes ma'am, they are: if one point and a slope is given, then equation will be y minus y1 is equal to m into x minus x1, and this is one point slope form. If 2 points are given, then equation will be y minus y1 is equal to y2 minus y1 upon x2 minus x1 into x minus x1, and this is 2 points form. But if we have both intercepts on the axis, then equation will be x upon a plus y upon b is equal to 1, and this is intercept form. If we have y-intercept and a slope, then equation will be y is equal to mx plus c, and this is slope-intercept form.
We have a few more forms of equations of straight lines which are quite useful in solving problems. We will study about them today. Observe this line L1. OM is the perpendicular drawn from the origin to the line L1. It is also called normal to the line L1. P is the length of the perpendicular OM, and omega is the angle made by it with the positive direction of x-axis. If the angle is measured in anti-clockwise direction, then it is positive, otherwise it is negative. We can determine the line L1 uniquely if we know the perpendicular length P and angle omega measured in the positive direction of x-axis.
Ma'am, angle omega is measured in anti-clockwise direction, but what about the direction of the perpendicular OM?
We always take this perpendicular distance for the line L2. The length of the perpendicular OP is 5 units and the angle omega measured in the anti-clockwise direction is 225 degree. For the line L3, the perpendicular length OP is again 5 units, but the angle omega is given to be 315 degree. Also observe that angle XOP is given to be 45 degree measured in the clockwise direction. So, we can also say that angle omega is equal to minus 45 degree. Now, let us determine the equation of the line L1 when the perpendicular length of OM is P and omega is the angle made by it in the positive direction of x-axis. Then we have OA upon OM is sec omega, and in this triangle BOM we have OB upon OM is cosec omega. So, here we have OA upon OM is sec omega. This implies OA is equal to OM sec omega, but since we know that perpendicular length OM is P, so we have OA is equal to P sec omega, and again we have OB upon OM is equal to cosec omega, which implies that OB is equal to P cosec omega. But observe again that OA and OB, they are x-intercepts and y-intercepts respectively. So, Nidhi, what will be the form of equation which we will use here?
Ma'am, we can use intercept form here.
Right. So, now we know that intercept form of equation is x upon a plus y upon b is equal to 1. This implies x upon a is the x-intercept, which was P sec omega, plus y upon b is the y-intercept, which is nothing but P cosec omega. This is equal to 1. This implies that x cos omega plus y sin omega is equal to P. We have taken P to the right hand side. Now, this is called the normal form of equation of a straight line. This form is quite useful when the perpendicular distance from the origin to a line is given or it is to be found. Now, here is a problem. Find the equation of the straight line if p is equal to 5 and omega is equal to 45 degree.
It's a straight application of the normal form which we have just learned, that is x cos omega plus y sin omega is equal to p.
So, you just said it is x cos omega plus y sin omega is equal to p. Now, we are given that omega is 45 degree and p is 5. So, straight away we can apply this. We have x cos 45 degree plus y sin 45 degree is equal to 5. We have just substituted the values, nothing else. So, this is x upon under root 2 because cos 45 is 1 upon under root 2, again y upon under root 2 because sin 45 is 1 upon under root 2, this is equal to 5. So, this gives us x plus y is equal to 5 under root 2.
Excuse me ma'am, if the equation of line is given, can we also find its perpendicular distance from the origin?
Yes, we can. Now, let us take this problem. Find the value of omega and p if the equation of a line is under root 3x minus y is equal to 2.
Comparing it with the form x cos omega plus y sin omega is equal to p. So, value of p should be equal to 2.
No, here you are wrong. If we compare the coefficients like this, then we should have cos omega is equal to under root 3 and sin omega is equal to minus 1, which is not possible. We have to compare all the coefficients together. So, we have to derive an expression for it which is always applicable. We know that the general form of equation of a straight line is ax plus by is equal to c, and the normal form of equation is x cos omega plus y sin omega is equal to p. So, comparing the coefficients all of them together, we have cos omega upon a is equal to sin omega upon b is equal to p upon c. This gives us cos omega is equal to ap upon c and sin omega is equal to bp upon c. Now, squaring these two expressions and adding them, we have cos square omega plus sin square omega is equal to a square plus b square into p square upon c square. But we know that cos square omega plus sin square omega is equal to 1. So, we have left hand side is equal to 1, is equal to the right hand side becomes a square plus b square upon c square into p square. This implies that p is equal to plus minus c upon under root of a square plus b square, but p has to be positive. So, we take this expression to be positive when c is positive and we take this negative sign when c is negative. In other words, we have to divide every term by under root of a square plus b square with the proper sign. So, now Nidhi, can you tell me how will you find out the value of p and omega from this given equation under root 3x minus y is equal to 2.
Oh yes ma'am, we will first divide both sides by under root 3 whole square plus minus 1 whole square, that is by plus root 4 or plus 2, as c is already positive.
You are right. So we then have under root 3 upon 2x minus y upon 2 is equal to 2 by 2. So we are dividing all the terms by under root of a square plus b square. This implies that cos omega is equal to under root 3 by 2 and sin omega is equal to minus 1 by 2 and p is equal to 1, and the value of omega which satisfies both these conditions is minus 30 degree or minus pi by 6. So the equation may also be written as x cos minus 30 degree plus y sin minus 30 degree is equal to 1.
Oh yes ma'am, now I understand how to transform the equation to the normal form.
We have one more form of equation of a straight line. A straight line is passing through a point A with coordinates x1, y1, and it is inclined at an angle of theta with the positive direction of x-axis. In order to find the equation of this line, we have to first of all take any point P such that AP is equal to R. Now we draw perpendiculars AL, PM on the x-axis and AN on PM. Then in triangle PAN, we have PN upon AP is sin theta and AN upon AP is cos theta. So here we have sin theta is Pn upon AP, but Pn is y minus y1 and AP is R. So we have sin theta is equal to y minus y1 upon R. This implies R is equal to y minus y1 upon sin theta. Also cos theta is equal to An upon AP, which is equal to x minus x1 upon R. This implies R is equal to x minus x1 upon cos theta, and thus we have y minus y1 upon sin theta is equal to x minus x1 upon cos theta. This is equal to R, implies that y minus y1 upon sin theta is equal to x minus x1 upon cos theta. This is called symmetric form of equation of a straight line.
Ma'am, I think this form can also be obtained from y minus y1 is equal to m into x minus x1 by replacing m by tan theta or sin theta upon cos theta.
So you are saying that we can use this form y minus y1 is equal to m into x minus x1. This gives us y minus y1 is equal to sin theta upon cos theta into x minus x1, which finally gives us y minus y1 upon sin theta is equal to x minus x1 upon cos theta, which is nothing but the symmetric form. This form is quite useful when we have to find out the coordinates of a moving point P with coordinates x, y. For that we have y minus y1 upon sin theta is equal to R. This is equal to x minus x1 upon cos theta. So the coordinates of P the y coordinate will be y1 plus r sin theta, and the x coordinate will be x1 plus r cos theta. Now observe these two equations. They also represent the equation of a straight line.
But here x and y are not directly related or connected as in other equations.
You are right, but here r is the parameter which relates x and y, and this form of equation is also called parametric form of equation. This is parametric form of equation of a straight line. We can eliminate r and get a relation between x and y. We have r is equal to x minus x1 upon cos theta, and again we have r is equal to y minus y1 upon sin theta. From these two equations we have x minus x1 upon cos theta is equal to y minus y1 upon sin theta. Now let us take a problem to see the application of this form of equation. The problem is, a line passes through a point A having coordinates 1, 4 and makes an angle of 135 degree with the positive direction of x-axis. Find the coordinates of the 2 points on either side of the point A lying on the line at a distance of 6 units from A. Nidhi, can you say which form of equation we will use here?
Since point of intersection and angle of inclination are given, so we can use point slope form to find the equation of the line. But we have to find the coordinates of the point at the distance of 6 units. It means r is equal to 6. So we can use parametric form here. Sorry ma'am, I am not able to understand which form will be more suitable.
Parametric form is more suitable here because we have to find out the coordinates of a point. Now we are given that the coordinates of a point is given by this formula, x is equal to x1 plus r cos theta. So x1 is given as 1 plus r is 6, cos theta is 135 degree. So we have 1 plus 6 cos 135 degree is minus 1 upon under root 2. So x is equal to 1 minus 3 under root 2. Similarly, for y coordinate we have y is equal to y1 plus r sin theta, which is equal to, now y1 is given as 4 here, 4 plus r is 6 sin 135 degree, which is equal to 4 plus 6 1 upon under root 2, because sin 135 degree is 1 upon under root 2. So y is equal to 4 plus 3 under root 2. So the coordinates of a point which is at one side of A is given by 1 minus 3 under root 2 and 4 plus 3 under root 2. Nidhi, can you now find out the coordinates of a point which is on the other side of point A?
Yes, I can. We will now take the value of r as minus 6.
Yes, when we take the value of r as minus 6, then we have the coordinates of that point as 1 plus 3 under root 2 and 4 minus 3 under root 2. Now let us take the same problem and find the distance of the point where this line meets another line x minus y plus 1 is equal to 0. Nidhi, can you find the distance?
As I think we will first find the point of intersection of the two lines by solving the two equations, and then we can easily find the distance between them.
Yes, we can use this method, but there is a shorter method also. Let us take the distance to be r. Then we have x is equal to 1 plus r cos 135 degree, which gives us x is equal to 1 minus r upon under root 2, because cos 135 degree is minus 1 upon under root 2. Also y is equal to 4 plus r sine 135 degree. So y is equal to 4 plus r upon under root 2, since sine 135 degree is 1 upon under root 2. But this point with coordinates x and y lies on the line x minus y plus 1 equal to 0. So substituting the value here, we have 1 minus r upon under root 2 minus, for y we substitute 4 plus r upon under root 2 plus 1 equal to 0. This implies 1 minus r upon under root 2 minus 4 minus r upon under root 2 plus 1 is equal to 0. This implies that minus 2r, simplifying this, we get minus 2r upon under root 2 is equal to 2. So r is equal to minus under root 2. Now the negative sign here implies that the point of intersection lies on the opposite side of the point A. This is point A. So the point of intersection is lying on the opposite side of A. But the distance is always positive. So r is 2, under root of 2. So we have different forms of equations of straight lines obtained under different conditions. These are, when we are given one point and slope, the equation is y minus y1 is equal to m into x minus x1, and this is called point slope form. When we are given 2 points, then the equation is y minus y1 is equal to y2 minus y1 upon x2 minus x1 into x minus x1. This is called 2-point form. When we have intercepts on both the axes, then the equation is x upon a plus y upon b is equal to 1, and this is called intercepts form. When we are given y-intercept and a slope, then the equation is y is equal to mx plus c, and the form is y-intercept slope form. We are given normal p and angle omega. In that case, the equation becomes x cos omega plus y sin omega is equal to p, and this is called normal form of equation of a straight line. In case we are given a point and an angle, then the equation is x minus x1 upon cos theta is equal to y minus y1 upon sin theta is equal to r, and this is called symmetric form of equation of a straight line. Now all these forms on simplification takes the form ax plus by plus c equal to 0, where both a and b are not equal to 0, and this is called general form of equation of a straight line.
So while solving problem, we find that equation of line is usually given in the general form, and we need to find the slope or intercept made by the line on the axis. They can't be found by just observing the line as in the particular form.
Yes, it is important. We just have to change the equation into the suitable form. For example, if we are given the equation like this, y is equal to minus 3 by 2x plus 6, then just by inspection or by observation we can say that the slope of this line is minus 3 by 2 and the y-intercept is 6. But if the same equation is given in the general form 3x plus 2y minus 12 equal to 0, then you can very well see that just by inspection we cannot find out what is the slope of this line or what is the y-intercept made here. So we have to change it to a suitable form. In case we want to find out, given this equation 3x plus 2y minus 12 equal to 0, and we have to find out the slope of this line and the y-intercept made by it, then the suitable form will be y is equal to minus 3 by 2x plus 6.
So ma'am, while transforming the equation of straight line into slope-intercept form, we have to take all the terms to the right hand side except that containing y, and then divide both the sides by the coefficient of y.
Yes, you are right. Now if the equation is given again 3x plus 2y minus 12 equal to 0, and we are asked to find out the x-intercept and y-intercept, then see how we change it to the suitable form. We have 3x plus 2y is equal to 12, but in intercept form of equation the right hand side should be equal to 1. So we take this 12 to the left hand side, 3x upon 12 plus 2 upon 12 y is equal to 1. This implies 1 by 4x plus 1 upon 6y is equal to 1. And now here just by inspection you can say that x-intercept is equal to 4 and y-intercept is equal to 6.
That is, to write the equation in the intercept form, we have to take the constant term towards the right hand side and then divide both the sides by the number on the right hand side.
Yes, you are right. Now again let us take the same equation, 3x plus 2y is equal to 12. And now here suppose we have to find out the perpendicular length p from the origin to the line. Then we use the normal form of equation, and we have to, that means, divide all the terms by under root of a square plus b square. But since 12 is positive, so we divide each of the term here by under root of 3 square plus 2 square, 2 upon again under root of 3 square plus 2 square into y is equal to 12 upon under root of 3 square plus 2 square. So this is the value of p. So we have then p is equal to 12 upon under root of 13.
Oh, that's a bit complicated. Here we have to take constant term towards right hand side and then make it positive. After this we have to divide both the sides by under root coefficient of x whole square plus coefficient of y whole square. Isn't it, ma'am?
Yes. So we always choose the right form of equation to get quick answers and avoid unnecessary calculations. We'll learn more about straight lines in our next lessons.
Thank you, ma'am. So friends, you know that mathematics is a subject in which the more we do, the more we learn. So try more and more questions related to these forms and keep learning and watching our program. See you in next lesson. Till then, bye-bye.